Hello students, in this video we're going to solve some very basic problems of physics from Unit 1 motion. Uh, these are problems, of course, just for uh, basic physics with a conceptual approach. So all these problems we're going to be solving are very simple problems. So in this first case, we have to calculate the velocity of a car in meters per second that starts from rest and accelerates at 5 meters per second square for 6 seconds. So what we have to keep in mind here, well, we can just make a sketch to understand better, the problem. So basically, we have a car that is at this point. This point have initial velocity 0 meters per second, you know, and uh, then is moving with an acceleration of 5 meters per second square during a time of 6 seconds. So what we want to know after these 6 seconds, what is the final velocity of this car. We know that the acceleration is equal to the variation in velocity divided by the variation of time. So this would be basically the final velocity minus the initial velocity over the time that took to the car to go from one point to the other. So since our car is starting at rest, we know that this initial velocity is 0. So now we have that the acceleration is equal to the final velocity over the time. So we solve for final velocity. Final velocity is equal to acceleration times time. So the final velocity would be 5 meters per second square times 6 seconds. The seconds squared and the seconds cancel out. So one of the seconds of the second square cancel with the second of the time. So we have our answer in meters per seconds. What is unit of velocity? So the final velocity, is just 5 times 6, 30 meters per second. Of course, in the same direction, of the acceleration. So if I said that the car was moving to the right, that was what I represent with this arrow over here. As there is an increase in velocity, then the vector velocity is also pointing to the right. So we can just now represent this as a vector with an arrow on top of BF. We have a velocity of 30 meters per second to the right, because to the right was the direction that I defined for the acceleration. So this was a very, very simple problem. Let us then go over this other. They say calculate a pendulum frequency of oscillation in hertz if the pendulum completes one cycle in 0.5 seconds. Again, let us just make a sketch of the problem. So we have a pendulum, right? So what happens, we have this pendulum that we're going to release at this position. There is an equilibrium position here. So the pendulum will move initially in this direction, and then it's going to reach this other extreme, and it's going to come back. So the time that takes the pendulum to leave position A, reach the position B here, that is the right extreme, of the trajectory of the pendulum, and then just come back to the position A, is what we call the period that we represent with the letter T. And this period is basically just the time that takes for the pendulum to complete one cycle. So the period would be 0.5 seconds. Now, there is a relation between the period and the frequency. So the frequency is the reciprocal of the period. So we can say that the frequency is 1 over 0.5 seconds. So 1 over 0.5 is 2, 1 over second, and 1 over second is hertz. So the frequency is 2 hertz. So it was very easy in this case to find the frequency of the pendulum. We have a third problem here where they say calculate the acceleration of a car in meters per second squared that accelerates from 0 to 30 meters per second in 6 seconds along a straight road. So what we have in this problem, and it's always a very good idea to make a sketch of the problem, to visualize what is going on. So I have my car here. At this initial point, its initial velocity is 0 meters per second, right? It's going to accelerate with an acceleration that is unknown. We don't know the magnitude of acceleration. And after 6 seconds, the velocity, in this case, the final velocity. Remember the difference between velocity and speed. It means when I'm talking about velocity, I'm talking about vector, have direction and magnitude. When I'm talking about speed, I'm just talking about magnitude. So when I say velocity here, is because I'm assuming that I'm working with the vector. As there is an increase in velocity, that vector is pointing in the same direction of the acceleration. I said the acceleration goes to the right, so the vector velocity goes also to the right. So the final velocity here would be 30 meters per second. So we're ready here to find the acceleration. We're going to use again the formula that we already know, that we already used. That is acceleration equals the variation in velocity over variation in time. So acceleration is the final velocity minus the initial velocity over the time. So initial velocity here is 0. So we're going to have that the acceleration is 30 meters per second divided by the time, there is 6 seconds, right? So of course 30 over 6 would be 5 meters per second over second would be meters per second squared. So in this case, the final of the acceleration, is 5 meters per second squared. We're solving a problem here where we have constant acceleration. These problems, the acceleration is constant. We have one last problem. No, two more problems. Sorry. We have one more problem here that says that a coin is rolled from the height and reaches a ground in 2 seconds. So they say from what height was the coin dropped. And we have no air resistance. So I'm going to make a sketch of my problem. I have my coin over here, right? So I don't know the distance from the point at which I drop the coin to the ground. So h, height, I don't know that, right? What I know that the time that took for the coin to reach the ground was 2 seconds. So if was dropped, and then don't give any information about the initial velocity, we're assuming that the initial velocity here is 0 meters per second. It was just released from your hand, imagine, you know. So you don't throw it, you just drop it. So we want to find what is the height here. So what we know a formula that said that the final position of a body along the y-axis is equal to the initial position plus uh, the initial velocity times the time plus, 1/2 gravity times the square of the time, right? Uh, Remember that when we have something that is falling, the acceleration is going to be acceleration of the gravity. I will use this y sub 0 on both sides, so I have delta y, it would be y minus y sub 0. So delta y is equal to initial velocity times the time plus 1 over 2 dt squared. What happened here? This initial velocity is 0, so the term v sub 0t becomes 0. Variation of position along the y-axis, that would be basically equivalent to the height, because I have an initial position at this level, a final position here. So that difference will be basically the height of, the coin, and that would be equal to 1 over 2 gt squared. So it would be 1 over 2 times 9.8 meters per second squared, times 2 seconds squared. So of course it will be 1 over 2 times 9.8 meters per second squared times 4 seconds squared. The second square cancel out here. So our output unit would be in meters. So this would be 9.6 meters. So in 2 seconds, if it took 2 seconds the coin to reach the ground, it is because the height at which we dropped the coin was 9.6 meters. And there is here a final problem. Let's say calculate the time in seconds needed for the car to accelerate from 0 meters per second to 10 meters per second at 5 meters per second squared. So what we know in this case, we have our car over here. So here we have an initial velocity of 0 meters per second. Here we have a final velocity, a final speed, 5 meters per second squared. Sorry, of 10 meters per second. We know that we have an acceleration that is 5 meters per second squared. So I know that the vector velocity is just going in that same direction. So I want to find the time that took to the body to go from the initial point to the final point. So we will again over the same formula that says, that acceleration is the variation of the velocity over variation of time. So this is final velocity minus initial over time. The initial is 0. So we're going to have the acceleration is bf over time. So now we multiply by time, both sides, so we get a times the time equals bf. We divide by the acceleration, so time is equals bf over the acceleration. So this is 10 meters per second square 10 meters per second divided by 5 meters per second square. This is velocity on the top. Divided by 5 meters per second square. So we cancel out here meters with meters, and this second with 1 over seconds in the second square. So below we get 1 over second in the denominator. So when we find the reciprocal, when we flip and multiply, it becomes seconds. So we have 10 over 5, and 10 over 5 is 2, and this is just 2 seconds. So the time that is taken, for the car to accelerate from 0 to 10 meters per second at 5 meters per second square is going to be 2 seconds. Well, these were just 5 very basic problems. I hope you know that these problems are going to help you to understand better this topic, and we're going to be recording just more of these videos. Thank you for your attention.